So in this video, we'll take a look at distance, what distance is, what it measures, and how to calculate the distance of a moving object. Distance is a measure of how far an object moves. The frame of reference is the actual object in motion. What we're looking at is what the object does. So if I say I walked 1.2 miles to the store, I've given you a distance. I'm telling you what I have done. I'm the object in motion, and I've told you how far I've moved. I have gone 1.2 miles. Another example of a distance would be the odometer on a car. This particular odometer says 99,483 miles. It is telling you that the distance the car traveled is 99,483 miles. Again, it's a distance because the frame of reference is the object that's in motion. It's the car that's moving. And it's telling us how far that car has traveled. That car has traveled 99,483 miles. Distance is independent of direction. In other words, direction doesn't matter. When I say I walk 1.2 miles to the store, it doesn't matter if the store is north, south, east, or west of my location. It also doesn't matter if I have to change directions along my route. All we care about is how far I have traveled, and I walked 1.2 miles. To find the distance an object travels, we add together each component of the object's motion, ignoring the direction of that motion. Here is a very simple example of what a distance word problem would look like. On a hike, Jackie walks 50 meters north, 25 meters east, then 30 meters south. What is the distance that Jackie travels? To find that distance, I would take each of those three components of motion, the 50 meters north, the 25 meters east, and the 30 meters south, and add them all together, ignoring the direction that we're traveling. So just 50 meters plus 25 meters plus 30 meters. Jackie has traveled 105 meters. Again, this is a distance because it tells us how far Jackie has traveled. She's the object in motion, and what we're being told is how far she has gone. As with position, we often use number lines when we do problems that involve distances. This time, though, because direction doesn't matter, we'll ignore the positive and negative signs. So let's say I have an object that goes through four components of motion. Assuming my object starts at 0, it starts by moving to position 2, and then it moves to position 4, then it moves to position -2, and then it moves to position -1. To figure out the distance that this mystery object has traveled, we have to figure out how many units it's moved in each of those four components of motion. So starting with number 1, if we started at 0 and moved to position number 2, we have moved 2 units. And again, that can be miles, meters, feet, whatever the case might be. Now starting at position 2, we move to position 4. That is another component that is equal to 2 units. Again, 2 meters, miles, feet, whatever the case might be. Then my object moves from position 4 to position -2. That is 1, 2, 3, 4, 5, 6 units. Again, meters, miles, feet, whatever the case might be. And then finally, from position -2 to position -1, that is a distance of 1 unit. That wraps up our list. Again, note that none of these are positive or negative. We just simply need to know the number of units we've moved in each component. Now to find the distance that our object travels, we'll simply add these four numbers together. So 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. Our object has moved 11 units, 11 feet, meters, or whatever the number line would be scaled to. You can find each of these four components by subtracting the numbers on your number line. To find a delta x in this case, you would take the final position minus the initial position. So here for my first component of motion, I went from 0 to 2. So I ended at 2, I started at 0, 2 minus 0 is 2. For my second component of motion, I went from 2 to 4. So again, we take where you ended at 4, subtract where you started, 2, 4 minus 2 is 2. To deal with the negatives, again, we're going to do the same thing. We're going to be subtracting where we ended, -2, and where we started, 4. -2 minus 4 is -6. We drop the negative sign because it's not important when it comes to distance. And then finally, -1 minus -2 gives us a difference of 1, which is another way of finding that last number. Again, no matter how you find them, you add those together to get your distance.